So welcome back to session 4 of arithmetic progressions. So until now we have come across what is a sequence, types of sequences, definition for arithmetic progressions with examples. So just I would take this time to recapitulate everything what we have done in the previous class. So according to the definitions what you have learned, a sequence is an orderly arrangement of numbers according to a given rule. A sequence is of two types, a finite sequence and an infinite sequence. So what is a finite sequence? A sequence having finite number of terms is called as a finite sequence. A finite sequence has nth term. What is an infinite sequence? An infinite sequence is a type of sequence in which it has no nth term. That is, it is made up of infinite number of terms. So next we come to arithmetic progressions. So what is an arithmetic progression, or what is an AP, short form of arithmetic progressions? So an arithmetic progression is a type of sequence in which the difference between a given term and its preceding term is always a constant. So that's called as an arithmetic progression. So today with some examples we had discussed yesterday. So today we will be going with some basic problems related to arithmetic progressions. So in this problems what we are going to come across today, it may come in your examinations for 1 mark. 1 mark questions we are going to come across. These problems I am going to call them as conceptual problems, because they are based on the concepts what you have learned in your previous class. So let us start with an example. In this example, or let us go with type 1 problems. So in these problems will be I am going to give you some arithmetic progressions. So using that arithmetic progressions you are going to find out the value of A and the value of D. So very simple problems, we will go with that. Right. Two comma 4 comma 6 comma 8 dot dot dot. So it is an arithmetic progression. So in this arithmetic progression, first term is 2, A is equal to 2 and D is equal to, usually we go with A2 minus A1 or any term minus preceding term will give you the common difference. Let us go with the universal method, that is A2 minus A1. So D is equal to A2 stands for 4 and A1 is 2. So therefore D is equal to 2. So in this AP, in this arithmetic progression, first term is 2 and common difference is also 2. So if the common difference, usually if it is positive, then the arithmetic progression will be, the terms of the arithmetic progression will be in the ascending order. The terms goes on increasing in its values if D is positive. Let us go with example 2. 12 comma 10 comma 8 comma 6 comma dot dot dot. So I have another AP here. So in this arithmetic progression, by inspection we can write A is equal to 12 and let us find out D. D is equal to A2 minus A1. So D is equal to A2 stands for 10 and A1 stands for 12. So D is equal to minus 2. So the value is negative. The value is negative. So therefore in the AP if you see this, the terms are in the descending order. The value of the terms in this AP are going on decreasing. So it is in the descending order. So this is the way of finding out A and D for the APs. So usually you can take D is equal to TA minus TP. So this is the usual formula what we used to use in the previous years when solving arithmetic progression problems to find out A. So D is equal to any term minus preceding term. That was the general formula we used to use to find out D. So now usually in textbooks also they use A2 minus A1. So A2 minus A1, therefore with this is also the Actually this is the thing we have to use. Any term minus preceding term means any term you can take. In this any term you can take 8. So minus preceding term of 8 is 6. So 8 minus 6, d is equal to 2. Same thing you are going to get here also, but this is the more generalized formula. So this is a little bit, I hope it is a restricted one to find out common difference. So in the next topic we will be going with some more problems related to AP. Now let us solve some more problems to find out the value of A and D when an AP is given. So this is example 3. So by this function we can write A is equal to minus 8. So this is the first term, so therefore it is indicated by A, that is minus 8. D is equal to A2 minus A1. So D is equal to A2 stands for minus 5, place it inside the brackets, put the minus sign. A1 is also negative, therefore it should be kept inside brackets to avoid simple mistakes. Alright, so D is equal to minus 5, minus into minus is plus 8, so that comes to 3. So what is the common difference? That is 3. So these type of problems usually they come in examinations. So you have to be very careful. So A2 is negative, keep it inside bracket. A1 is negative, keep it inside brackets, just to avoid simple mistakes while doing problems. So let us go with the example 4. 4 root 2, 3 root 2, 2 root 2, dot is in AP. So by instruction we can write A is equal to 4 root 2. This is one of the result. So D is equal to A2 minus A1. So D is equal to A2 stands for 3 root 2 minus A1 is 4 root 2. So D is equal to, when you take root 2 as common, you get 3 minus 4. So D is equal to root 2 into 3 minus 4 stands for minus 1. So minus 1 into root 2 is D is equal to minus root 2 or minus 1 root 2 or minus root 2. So this is the value of D. Now, this is the very important part of arithmetic progressions. So in this module we are going to derive the formula used to find the nth term of an AP. Nth term of an AP in the sense, generally each and every term of an AP, how it looks. How each and every term of an AP looks generally based on its first term and common difference. So that's called the nth term of an AP. I want to repeat this. What is the nth term of an AP or general term of an AP is that how each and every term of an AP looks generally depending upon its first term and common difference is called the nth term of an AP. In other words, the general term of an AP. So once we are able to derive the general term of an AP, we will be able to write the general form of an AP also. So in this module I am going to teach you, right, I am going to present you how we get the nth term of an AP and the general form of an AP. So we know that, let us consider this as book work 1 because it's a very small derivation. Let us take it as book work 1. So next derivation will be book work 2, next derivation will be book work 3, something like that. So if you are aware of this, this is the basic, this is the conceptual learning. If you are aware of this when it comes, you will be able to solve any problems on nth term of an AP. Now let A1, comma A2, comma A3, comma A4, comma AN, B and AP. This is a sequence. A sequence can become an AP. So therefore, let A1, A2, A3, A4 until AN, BN, AP. So in this, let A be the first term. Let A be the first term and D be common difference. first term and d be the common difference. So now a1 is nothing but the term a. a1 is, let a be the first term, I have announced this. So a1 is nothing but a. So as per the knowledge we have regarding the first term of an AP, so first term of an AP and the common difference, they are not related. In the sense, we do not get the first term by adding common difference to any number. So first term comes from anywhere. So it is not connected to the common difference. So therefore, a1 is a, which can be written as d is not added to something to get a. So that is how we are going to write it mathematically. A is equal to a plus 1 minus 1 into d. So that is 1 minus 1 is 0. 0 into d is 0. 0 plus a is again a. So first term is a. So 0 times common difference added to the first term. That is the meaning of the mathematical statement. So according to the concept what we have learned yesterday in previous class, if you want to get the second term in an AP, you have to add one time common difference to the first term. That was the thing what we had learned in the previous class. So if you add one time common difference to the first term, you are going to get the second term. So that concept I am going to write it down on the board mathematically. So let us see how it goes. So this is the first term. I am going to add one time common difference to this. A plus 1d. So this a plus 1d or just a plus d can be written as a plus 1d. I am going to write it as 2 minus 1 into d. Same thing comes. 2 minus 1 is 1. 1 into d. D plus a is a plus d. So second term is a plus d. Let us go with the third term. That is, again we have to remember the concept of yesterday's. So if you add 2 times common difference to the first term, we are going to get the third term that we had discussed in the previous class. So once again, if you are going to add 1 time common difference to the first term, you get the second term. If you are going to add 2 times common difference to the first term, you are going to get the third term. That I am going to write. So a3 is the third term. So first term you are going to add 2 times the common difference. That is d plus d. D plus d is 2d. So a plus 2d I am going to write it in this form. A plus 2 can be written as 3 minus 1 into d. So this is 3 minus 1 is 2. 2 into d. 2d. 2d plus a is a plus 2d. So this is the third term. So let us go with the fourth term. It comes. So again, remember the concept. When you add 1 time common difference to the first term, you get the second term. 2 times common difference to the first term, you get the third term. Similarly, if you add 3 times common difference to the first term, you are going to get the fourth term. So this I am going to write. So a plus, I am going to add 3 times common difference to the first term. So d plus d plus d. So d plus d plus d is nothing but 3d. So I am going to add 3d. So this becomes a. I am going to write wherever it is. 3d can be written as 4 minus 1 into d. So this is how we get the fourth term. 4 minus 1 is 3. 3 into d, 3d. 3d plus a is a plus 3d. So similarly, when I come down, at last I am having the nth term. I am having the nth term. So how to write the nth term? So an is equal to, now leave this, take these lines. So in this generalized form of the terms of the AP, A is repeated in the sense if you want the nth term of the given AP, for the first term you have to add n minus 1 times the common difference. So that comes A repeats A plus, what is this here? 1, 2, 3, 4, they are natural numbers. I am going to write n, minus 1 continuous and d continuous. So if you want the nth term of an AP, you want the nth term of an AP, right, for the first term of that AP, you have to add n minus 1 times the common difference. So this is the formula used to find the nth term of an AP, or it is called the general term of an AP. So here, by using this general, that is nth term of an AP, we can write the general form of an AP also. General form of an AP, how it comes? First term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D. Can you guess the fifth term? That comes A plus 4D, dot 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 dot. What is the general form of nth term of an AP? That is A plus n minus 1 into D. So this is the general form of an AP. This is the general term of an AP, and this is the general form of an AP. So this will be asked for 1 mark. Write the nth term of an AP. Write the formula to find the nth term of an AP. So I have to write this: an is equal to a plus n minus 1 into d. That means if you want the nth term of any AP or given term of any AP, then to the first term of that AP, add n minus 1 times the common difference of that AP, you will get the required term. So this is the general form. Any AP will be in this form: A plus D, second term A plus 2D, A plus 3D, A plus 4D, dot dot dot, and the nth term is A plus n minus 1 into D. Now, a very important concept you have to remember here, as this nth term has two properties, what we have discussed in the last class. So A represents the last term of the AP, as well as it represents the general term of the AP. So therefore, nth term of an AP is also the last term of the AP, which is equal to A plus n minus 1 into D. So this is the thing you have to remember. So AN represents the general term of the AP, as well as AN represents the last term of the AP. So this is the bookwork for our very simple derivation to find to get the nth term of an AP and general form of an AP. So in the examinations you are going to come across a question like this. You will be given the nth term of an AP and you will be asked whether to check it is an AP or not. That's a very simple question. The question goes like this. You will be given the nth term of an AP. Some AP nth term they will give you, and they will ask you to check whether that is the nth term of an AP or not. That's a very simple thing. Usually what we do is, we take the nth term of that AP, we will find out its first term, we will find out its second term, we will find out its third term, then do A2 minus A1, then do A3 minus A2, and we will see that if the common difference is constant. So if the common difference is constant, then we announce that it is an AP, or if the common difference is not constant, then we say that it is not an AP. So this is the usual method of checking out whether the given nth term of a sequence is an AP or not. But here in today's class, I am going to discuss a very interesting method of finding out whether the nth term of a given sequence is an AP or not. That's a very simple technique. It's very interesting. You really will enjoy it. Now, show that sequence defined by an is equal to 2n square plus 1 is not an AP. Just we have to check that it is not an AP. We have to prove that it is not an AP. So let us take the nth term. An is equal to 2n square plus 1. Find out an plus 1. Nth term will be given to you. So you find out an plus 1. An plus 1 comes next to an. So there is a succeeding term of an, that is an plus 1. So in place of n, you have to put n plus 1. So square continues plus 1. So an plus 1 is equal to 2 into n plus 1 whole square comes n square plus 1 plus 2n plus 1. So this is a plus b whole square formula. This is a square plus b square plus this is 2ab. 2 into n into 1 is 2n. So an plus 1 is equal to okay, let us multiply this. 2 into n square is 2n square plus 2 into 1 is 2 plus 2 into 2n is 4n plus 1. Add these two constants. So an plus 1 is equal to 2n square plus 4n plus 2 plus 1 is 3. So I have written in the standard form. So this is an plus 1. So now subtract. Actually after an you get an plus 1 in the name, isn't it? So in order to find out d, what we do is we take this as the given term and this as the preceding term. So an plus 1 minus an should give you common difference. So let us do it. An plus 1 minus an is equal to an plus 1 is 2n square plus 4n plus 3 minus nth term is 2n square plus 1. So an plus 1 minus an is equal to multiply by 1 2n square plus 4n plus 3 minus 2 minus into plus 2n square is minus 2n square minus into plus 1 is minus 1. So minus 2n square plus 2n square cancels. So an plus 1 minus an is equal to the remaining thing is 4n plus 3 minus 1 is plus 2. So this is we have got. So this is nothing but the value of d. 4n plus 2 is nothing but d. So here very important thing is the value of d what you have got here is 4n plus 2. So d is equal to 4n plus 2. So here as d is equal to 4n plus 2, d is not independent of n. The value of d is not independent of n. The value of d has n inside it. So therefore, as d is not a constant, as d is not a constant because n indicates the natural number. You can substitute any number in the place of n. Therefore, the value of this goes on changing continuously. So therefore, as d is not independent of n in its value, therefore d is not a constant. So as d is not a constant, therefore the given nth term of that sequence is not an AP. This is how we can come to a conclusion. I hope you got it. Once again, the value of d what we get here should be independent of n. In the sense, it should not have any value of n inside it. So here it has n inside it. So therefore this entire value is not a constant. The value of d goes on continuously changing. Therefore d is not a constant. Therefore the nth term of this given sequence do not form an AP. So you can check this by substituting n is equal to 1, n is equal to 2, n is equal to 3 by checking out whether the given thing is a constant or not. You can check it. Then also you will come to the last conclusion that this is not an AP. So how can you come to a conclusion? If d is independent, if d is not independent of n, then the nth term of that sequence is not an AP. Okay. Now let us look at the second problem where you will be given the nth term of an AP. So using the concept what I am going to teach you now, we can directly tell whether the nth term of a sequence is an AP or not. So very simple. So an is given to you. An is equal to 3n minus 2. Find out an plus 1 by substituting n plus 1 in the place of n. So 3 into n plus 1 minus 2. So an plus 1 is equal to 3n plus 3 into plus 1 is plus 3 minus 2. So an plus 1 is equal to 3n plus 1. So now in order to find out d, usually we take an plus 1 minus an. So that will do it. So an plus 1 minus an is nothing but d. So an plus 1 value is 3n plus 1 minus nth term, that is 3n minus 2. So an plus 1 minus an is equal to 3n plus 1. Minus into plus 3n is minus 3n. Minus into minus 2 is plus 2. So an plus 1 minus an is equal to plus 3n minus 3n cancels. Plus 1 plus 2 comes 3, which is nothing but equal to d. So what the value of d we have got here? D is equal to 3 we have got. So what is d? So here the value of d is independent of n. So in the last problem we had d is equal to something which had n inside it. But here d is equal to 3, which is a constant. So if the nth term of a sequence has d independent of n, then the nth term of that sequence becomes an AP. So I am going to conclude with two very important statements. Listen very carefully. If the nth term of a sequence is independent of n, then it is an AP. If the nth term of a sequence is not independent of n, then it is not an AP. So if you want the nth term of a sequence to be an AP, usually what we do is we look at the nth term of the AP and check whether it is in the linear form. So you can see here it is in the linear form. N, the power of n is 1. So nth term is a linear expression. If the nth term of a given sequence is a linear expression, no doubt in that, don't think anything, just directly announce that, sir, that sequence nth term is an AP. So if the nth term of a given sequence is in the linear form, 100% the given sequence will be an AP. This is a very important concept, please remember this. Now we will continue with the conceptual problems related to AP. Very simple. Write the AP if A is equal to 4 and D is equal to minus 3. So we have some AP whose first term is given and common difference is given. So using the first term and common difference, you have to write the AP itself. In the coming next 3 mark questions and 4 mark questions, this will be one of the last step while solving those problems. So this is the conceptual development. Write the AP if A is equal to 4 and D is equal to minus 3. So as I have told you to write the AP, we can take the help of the general form of the AP. So in order to define an AP, first 3 terms are enough. Don't write 4th, 5th, 6th and all. Just write first 3 terms of that AP. It's enough to define an AP. Right. So general form is given by AP is given by A plus D, A plus 2D, dot. So here A is 4, write 4, A is again 4 plus D is minus 3, keep it inside brackets, comma A is 4 plus 2 into D is again minus 3, it continues. So simplify this, 4 comma plus into minus is minus 4 minus 3 is 1 comma plus into minus, that is minus 2 3s are 6, 4 minus 6 is minus 2 dot. So this is the required AP. Right, so in the first term, common difference of an AP are given. This is the method of finding out the AP. First 3 terms are enough. So let us go with the next question. Write the AP if A is equal to minus 1 and D is equal to 1 by 2. Fraction is given, no problem. So general form of AP is A plus D, A plus 2D, dot. So A is minus 1, let us substitute that, minus 1 plus D is 1 by 2, comma A is again minus 1 plus 2 into D, that is 2 into 1 by 2, comma dot. So here minus 1 continues, minus 1 has denominator, take LCM for 1 and 2, that is 2, minus 1 by 1 into 2 is minus 2 plus 1 by 2 into 2 is 1, comma, minus 1 plus 2 and 2 cancels, you have 1, comma, dot dot dot, another one step, minus 1, comma, minus 2 plus 1 is minus 1 by 2, comma, minus 1 plus 1 cancels and it is 0, dot dot dot. So this is the required AP. So by using the first term and common difference, this is the method of finding out the required AP. So we have the third problem here. A is equal to minus 1.5 and D is equal to minus 0.5. So I have given this as a homework to you. You try yourself and get the required AP. Right. So dear students, I hope you enjoyed today's class. So tomorrow morning I am going to send you the notes on WhatsApp. Please update yourself with the notes. And in tomorrow's class I am going to solve very simple problems on the nth term of the AP. So you can send your comments on WhatsApp or on the YouTube channel itself, and you can clarify any required doubts. I hope you enjoyed this. So tomorrow's class will be very important one, that is the building block for an AP, big problems. These are the basics. So in tomorrow's class we will be solving some 2 more questions related to AP. Take this as type 1, 2 and 3. Type 3 problems until now they have been completed. So be with the syllabus, be with the content, revise it. You can see the videos 1 or more times you require. I am not going to privatize it. It's always left to the public. You see it 2 or 3 times. If you have any doubts, you can just clarify through your WhatsApp. So please subscribe the channel SP Gubbi online classes so that we can reach more number of people. So thank you once again. Be home, stay safe, stay home. Wish you all the best.